Hello students, in the previous video we learnt about the laws of exponents for real numbers. In this video we will apply those laws to solve problems where bases have been raised to certain powers, indices or exponents. Let us proceed with the first problem. Now, is this a perfect square? That is what we need to see first. Yes, 64 is a perfect square of 8. So we can put this down as 8 square raised to half. Okay, 64 is a perfect square of 8. So we can say 8 square, which is nothing but 64. Whole thing raised to half. Now this is in this form, a raised to m whole thing raised to n, and we know that in this case the powers get multiplied because the base is the same. So similarly over here we put this in brackets and we multiply the powers. 2 into half, 2 and 2 gets cancelled, and this is 8 raised to 1, which is 8. The previous problem could also be solved by factorization. So in factorization we factorize always with prime number. So we'll take 2 as a prime number. 2, 32, 16, 8, 4, 32 and 1. So we have 1, 2, 3, 4, 5, 6. So we can take this as 2 raised to 6 whole thing raised to half, and 2 will be, this powers get multiplied, so 6 into half, 2 ones are 2, 2 threes are 6. So 2 raised to 3 is what we get, which we can write as 2 into 2 into 2, which is nothing but 8. Same as the previous answer but in a different way. So we can also get this in case of factorization. So if we know that it is a perfect square, we can go ahead with it. Let's move to the next problem. Next problem is 32 raised to 1 upon 5. So let us factorize in this case because this is not a perfect square. So 32 again goes with 2 times table. So we have 1, 2, 3, 4, 5. So 2 is repeated 5 times. So we can put it 2 into 2 raised to 5 whole thing raised to 1 upon 5. Powers get multiplied. 2 into 5 into 1 upon 5. 5 gets cancelled. 2 raised to 1, which is 2. Easy. So here once again is the same law applicable. A raised to m whole thing raised to n, where m and n get multiplied because the base remains the same. Let's do the next problem. Next problem is 125 raised to 1 upon 3. This is not a perfect square, so let us factorize. So the unit place is 5, that means it will definitely go in 5 times table. So 5 2s are 10, carry 2, 5, 5 5s are 25, 5 5s are 25. Okay, so 5 is repeated 3 times, so this will be 5 raised to 3 whole thing raised to 1 upon 3. Powers get multiplied once again because it is the same law. 3 gets cancelled and we are left with 5 raised to 1, which is 5. So once again the same law is applied, and through factorization we are able to solve this problem. Let's go to the next problem. Our next problem is 9 raised to 3 upon 2. So 9 is a perfect square of 3. So no need to factorize. We can put this as 3 square whole thing raised to 3 upon 2. And now we can multiply the powers because the base is the same. So 3 into 2 into 3 upon 2. 2 gets cancelled and we are left with 3 raised to 3, which is 3 into 3 into 3. 3 3s are 9, 9 3s are 27. And we get 27 as the answer for 9 raised to 3 upon 2. Let's solve another one. Our next problem is 32 raised to 2 upon 5. So 32, let's find out the factors of 32. 2 into 16, 2 8s are 16, 2 4s are 8, 2 2s are 4, 2 1s are 2. So once again I took prime numbers. Always take prime numbers for factorization. Okay, which are the prime numbers? 2, 3, 5, 7, 11 and 13 and so forth. Okay, to factorize the number that is given to you. So here we get 1, 2, 3, 4, 5. So that means 32 is nothing but 2 raised to 5 and whole thing is raised to 2 upon 5. So the powers get multiplied. So 2 into 5, 2 raised to 5 into 2 upon 5. 5 gets cancelled. We are left with 2 raised to 2, which is 4. Easy? Let us continue solving few more problems. Our next problem is 16 raised to 3 upon 4. Now 16 is a perfect square of 4. Okay, but if you take 4 over here, I'll show you what will happen. 4 square, you can say, raised to 3 upon 4. Powers get multiplied. 4 into 2 into 3 upon 4. 2 1s are 2, 2 2s are 4, and you will be left with 4 raised to 3 upon 2. And again you will have to carry out another problem where 4 is actually whole square of 2. So 2 square whole thing raised to 3 upon 2, and then 2 gets the powers get multiplied. 2 into 3 upon 2, 2 get cancelled. We are left with 2 raised to 3, which is equal to 8. This becomes fairly long. So not always do you go in for solving with perfect squares. See what your power is. Instead of taking a perfect square, let's factorize and see if we can get it a little bit smaller. So we'll go with 2 times table. 2 8s are 16, 2 4s are 8, 2 2s are 4, 2 1s are 2. So 4 times 2 gives us 16. So instead of this step, if we had to write 2 raised to 4, because we get 2 4 times on factorization, whole thing raised to 3 upon 4, and we multiply the powers 3 upon 4, where 4 gets cancelled, we would have been left with 2 raised to 3, which is 8. See this step, 1 2 3 4. Within 4 steps we complete the problem, whereas over here we have additional step 1 2 3 4 and then 5 6 7. So 3 additional steps. To avoid that thing, first you take a good guess. First objective is, can we get rid of the denominator? Because if we can get rid of the denominator in the power, then we can easily get our solution. But if not, then we may have to go in for few additional steps. So here in this case it is better not to take a perfect square because of the additional steps. Rather go for factorization and go for a base that is lower but giving a power that can be cancelled with the other power, so that we get our answer a little bit faster in few steps. Got it? We'll move to the next question. Before we proceed towards the next step, just letting you know that irrespective of the method that you take, whether you go for the perfect square or you go for factorization, as long as the working is correct and you get the same answer, you will get your marks. So it doesn't matter whether you take a perfect square or whether you factorize. Both ways it is correct. It is all about saving time by reducing steps. Okay. Let's move to the next question, which says 125 raised to minus 1 upon 3. So this is the form that I had told you. If it is x raised to minus n, then what happens? We put it in the denominator. The base goes in the denominator, wherein the power becomes positive. So over here as well we put it 1 upon 125 raised to 1 upon 3. The power becomes positive in this case. And now we factorize the base, which is not a perfect square. So 5 2s are 10, 5 5s are 25, 5 5s are 25, 5 1s are 5. So 3 times 5, That means 1 upon 5 cube whole thing multiplied by 1 upon 3. Here 1 upon 5, 3 into 1 upon 3. So the powers get multiplied, 3 gets cancelled, and we are left with 1 upon 5 as the answer. Okay, so 1 upon 5 is our answer. So just be careful whenever we get a negative sign in the power, we need to put the base in the denominator. Okay, so that how the power of the base becomes positive. Let's solve new problems. Our next problem says 2 raised to 2 upon 3 into 2 raised to 1 upon 5. So in this case, the bases are the same, but the powers are different. So this is in this form: a raised to m into a raised to n. Okay, since the bases are same, we add the powers. So m plus n. Similarly over here we'll do 2 into 2 raised to 2 upon 3, put this in bracket, plus 1 upon 5. The powers get added. Now we can't add them because the denominators are different. We need to make sure the denominators are the same, so we need to take an LCM. So 2 raised to 5 2s are 10, 3 10 upon 15 plus 3 into 1 3 upon 15. So I multiplied, in this case 2 upon 3 was multiplied with 5 in the numerator and denominator. So when 5 into 2 gives us 10, 5 into 3 gives us 15, and to make this 15 we multiply this by 3 in the denominator and also multiply 3 in the numerator to balance it. Hence we get 10 upon 15 plus 3 upon 15. Put this in our bracket, and now we add. So 10 plus 3 upon 15, this can be written as 2 raised to 13 upon 15, and that gives our solution. We don't need to solve any further. It will give us a big number, not necessary. So this is the answer that we get upon solving this question. Okay, so our new problem says 1 upon 3 raised to 3, the whole thing is raised to 7. So this can be written as 1 raised to 7 upon 3 raised to 3, whole thing raised to 7. That makes it easier for us to understand. In this case, 1 raised to 7 remains 1 because it's 7 times 1 getting multiplied with each other. It doesn't matter how many times you multiply 1, the answer will always be 1. In this case, the powers get multiplied. So 3 raised to 3 into 7, that will come to 1 upon 3 raised to 21, and that is our answer. Got it? Let's move to the next question. The next problem says 11 raised to half upon 11 raised to 1 upon 4. So this is in this form wherein the power is the same, the base is the same, but the powers are different in division problem. Then in this case we get a raised to m minus n. So even here we will have to raise this, subtract half minus 1 upon 4. We will have to get a LCM over here, which we get as, so we'll keep this as 4 and multiply it over here in the numerator and denominator by 2. So we get 2 upon 4 minus 1 upon 4. And now that we have got the denominator the same, we can subtract 2 minus 1 upon 4. So that we'll get as 11 raised to 1 upon 4, and that is our answer. Right? Our next problem says 7 raised to half into 8 raised to half. Here the bases are different. So this is in this form: a raised to m into b raised to m. So we can club them together and raise it to the common power. So even here we need to do the same, 7 into 8 whole thing raised to half, which we can write as 7 into 8 is 56 raised to half, and that is our answer. Okay, so we get 7 into 8, that is 56 raised to half. Okay, and we take a special problem, our last problem of this video. We have 125 raised to minus 1 and 375 raised to 0. So to avoid confusion, we'll keep this the way it is, 125 raised to minus 1. We know any base raised to 0 is always equal to 1, because I had told you x raised to 0 is equal to 1. So it doesn't matter what the base is. If it is raised to 0, then the answer will always be equal to 1. So 375 raised to 0, we can write it as 1. Now, I had also told you any base raised to the minus 1, it will come in fraction where this power becomes positive. Okay, so same way over here, we'll have to get this as a fraction. Now that the denominators become 1, there is no confusion. 125 raised to minus 1 can be written as 1 upon 125. So that is the answer to this problem. Remember, anything raised to 0 is always 1, and anything raised to minus 1, the base comes in the denominator and the power becomes positive. Okay, so with this we end solution to the problems on laws of exponents for real numbers. I hope it served you well in understanding how to use the laws of exponents. Watch the next video to learn more about real numbers. Thank you for watching.